Bismillahirrahmanirrahim. First, vacuum tube and transistor. Before 1947, in the invention of the transistor, the electronic tube was the first basis of virtually all the electronic devices. The simplest kind of electronic tube is the diode, which was invented in 1904 by John A. Fleming. Before 1947, vacuum tube was used for switching purpose and it consists of a diode. This is the electronic tube, which is a simply diode, and this was used for the switching purpose. These are the electronic tubes of different kinds, and these tubes were used to develop a computer, to develop a logic circuit. For example, this is the circuit diagram which is developed based on these electronic tubes, and this is the computer which consists of this circuit and which is based on electronic tubes, and this is the simplest computer before 1947. This is the electronic tube and this one is its circuit. It consists of a glass which is covering all the area, and an anode and a cathode, and there is a heated cathode. It generates heat, and when it generates heat, then current passes through this vacuum tube to the anode side. From anode to cathode the current flows, due to which the switching purpose is achieved. So this is the simplest logic circuit which was used to develop the computers before 1947. Discrete logic integrated circuits. When the transistor is developed, then after transistor different kinds of discrete logics were developed based on these transistors. For example, AND gate, it is a fixed logic which is developed based on transistor, and OR gate, which is also has a circuit based on transistor, NOT gate, NAND gate, XOR gate, all these logic gates were developed based on these transistor circuits. And this is the picture of an integrated circuit which consists of this kind of logic integrated circuits. This is the transistor logic gates diagram. For example, this is the AND gate, which is its logic is developed using transistor. This is the transistor based AND gate, transistor based OR gate. This is the transistor based NOT gate. This is the NOR gate, and this is the NAND gate. All these circuits are developed based on transistor logic, and these are its symbol. For example, this is the symbol of AND gate. This is the gate of NOR gate symbol, OR gate symbol, NOT gate, and this is the NAND gate symbol. Combination logic or the fixed logic. Based on these logic circuits, AND gate, OR gate, NAND gate, NOR gate, these are the logic gates. Based on these logic gates, a combinational logic was developed to implement some special function. For example, this is a 7-segment display circuit, and this is developed using these kind of logic gates. This is its diagram, circuit diagram, and this is the practical logic circuit board to implement a 7-segment display on the board. This is the LED. These are the gates. Here the input, and then input is supplied to these are the NOR gates, and then this is transferred to these are ICs of the gates. These are the ICs which perform a specific function. For example, this is the AND gate IC, this is the OR gate IC, and so on. These are the ICs which have a specific function, specific task to perform. Combination logic, fixed logic. Combinational circuits are designed with discrete logic ICs from transistor logic or CMOS families. Combinational circuits have fixed logic designed to perform specific tasks. These are fixed circuits to perform a specific task. If specifications for application changes for some reason, all the design has to be redesigned on paper and also on the printed circuit board or PCBs of the circuit has to be changed accordingly. If the design is changed, then you need to change all the things related to this kind of combination circuit on the PCB and on the design. All combinational circuits are designed against some predefined logic for specific truth table for combination of inputs and outputs. To simplify the logic combination, Boolean algebraic equations, timing diagram, and Karnaugh maps are used. Combinational circuits are getting obsolete after development of microprocessor and microcontrollers. These combination circuits are now obsolete due to development of microprocessor and microcontrollers. For example, here is a circuit. These are the binary inputs A, B, C, D, and these are the decoder outputs, and this is the 7-segment display. This input, when given to decoder, this decoder decodes it and generates a 0 on the screen. When this input is given to decoder, it decodes it and generates 1 on the screen, and so on. For example, these are the two inputs X and Y. These are output for the AND gate, OR gate, NOR gate. When input are 0 0, AND gate is 0, OR gate is 0, and NOR gate is 1. 1 0, AND gate is 0, OR gate is 1, and the NOR gate is 0, and so on. You can check it out. And here there is the Karnaugh map, AB on the one side and CD on the other side. When these logics are combined, for example, 4 0 are used to develop 0, and this is the binary equivalent of 1, this is the binary equivalent of 2, 3, 4, 5, 6, 7, and up to 15. You can develop the display circuits using this kind of logics. First microprocessor was 4004. Intel introduced its first 4-bit microprocessor 4004 in 1971, and its 8-bit microprocessor was 8008 in 1972. It was developed in 1972. During the 1960s, computer processors were constructed out of small and medium scale ICs, each containing from tens of transistors to a few hundred. In 1960s, the computer were developed with the medium scale ICs. For example, this is an IC, and many ICs were used to develop a computer circuit like this, and then this was then used as a computer. Programmable logic. Microprocessors and microcontrollers are the programmable logic controllers. For example, microprocessor. Programmable logic circuits are designed with the microprocessor or microcontroller. Architecture of microprocessor and microcontroller based circuits are normally generalized as per manufacturer's data sheet. All microprocessors have common interfaces like address port, data port, control signals, interrupts, power supply inputs. To develop a microprocessor control based circuit, all the supporting components like ROM, RAM, MUX, clock circuit, buffers, analog to digital converter, digital to analog converter, UART, and the ports are connected with the microprocessor externally. All these ports are connected with the microprocessor externally in microprocessor. A port is an interface to connect real-world parameters like digital inputs, digital outputs, analog inputs, and analog output with the microprocessor. Different kinds of ports are used to connect the real-world parameter with the microprocessor. This is the data bus, this is the address bus, and all these things are connected externally with the microprocessor. These are the ports for clock, reset, and the voltages, VCC and VSS. This is the microprocessor based circuit which is programmable, and a program is made for this microprocessor and burned into the microprocessor memory, and then based on this program it performs specific functions or tasks. So this is the circuit which was developed, which is used to perform specific functions based on microprocessor. Microprocessor based control circuits are like this. These are the computer or the microprocessor based circuits. These are the different kinds of microprocessor chips which are placed into this IC, and these were connected with one another to perform this kind of specific programmable logic function. Microcontrollers are also programmable logic developer. A microcontroller is also a programmable logic device with the required interfaces like ROM, RAM, MUX, clock circuit, buffers, ADC, DAC, and UART are installed inside the chip. Only ports are available to user to develop required control circuit. These are all things, ROM, RAM, and all other things are connected inside the chip of the microprocessor. In case of microprocessor, all these things, in case of microcontroller, all these things are connected externally. But in case of microprocessor, in case of microcontroller, all these things are inserted inside the chip of the microprocessor, which makes it microcontroller. Normally, microcontrollers are used to perform specific tasks like temperature controller, power backup systems, communication devices, flight controllers. These are all the ports, inputs, data bus, and the address bus are inserted inside the microprocessor chip, and which makes it microcontroller. In microprocessor, all these things are connected externally, but in case of microcontroller, all these things are connected inside the chip. This is the microcontroller based circuit which is programmable, which is programmed to perform some specific task, to perform some specific function. So this is you can see that all the inputs ports and the output ports are connected with some devices to perform a specific task. This is the microcontroller based circuit. You can see this is one microcontroller. Here is one microcontroller, and all the things, inputs and outputs, are connected with it through this microcontroller to perform a specific task. And there is a software for creating programs. For example, this is a program or a code which is then assembled and boiled into the microcontroller, which performs specific function and decodes its information and works on it based on this information. Software programming is like this. This is a program which is transferred into the memory of this 8051 microcontroller, and based on this program it turns off or on its output to perform a specific task. So these are the microcontrollers and the microprocessors information, the details which were used to perform a specific function, specific task based on its programming. Thank you so much for watching this video.